very amateur to mediocre level is done with the help of a library known as OpenCV, which is available on Java, Python, as well as C++. OpenCV has more than 2,500 optimized algorithms OpenCV, like extracting 3D models, producing 3D point clouds from stereo cameras, etc., etc. It's all written. Uh, and some companies that use OpenCV for their go-to operations are IBM, Honda, Toyota, Yahoo, Google, Intel. Intel is actually the company that has made OpenCV. So drawing text and shapes on images. So basically, that is one of the very basic functions of OpenCV. You can just write 2 3 lines of code and draw any text or shape, which is a really beginner stuff. So you can do that, but it is also helpful in highlighting a particular point of image that has been recognized in face recognition or object recognition. Then another function is thresholding. Thresholding is basically a kind of a phenomena where what we do is, as you know, that every pixel in an image can be represented in the form of an array. This array consists of several numbers, and these numbers can be modified according to our needs. So the more we modify these numbers in the forms of zeros and ones, the more it is clear, right?
Guys,
So that is where we use.
so we got a new visitor. So can you start? Or
Yeah, so Anish, I'll start all over again once we finish this time. Okay.
Yeah,
Uh,
let's one
yeah,
run through because every time if someone comes, we cannot start. So we'll explain him from that part only in short again. Pamitra, continue from there.
Yeah, so I'll explain thresholding again. Thresholding is that every pixel in an image can be expressed in the form of an array. So it can be a 2D array or a 1D array, and this array consists of several numbers. These numbers are modified according to our needs, and then image editing takes place. So in thresholding, what we do is we convert these numbers in the reduced form of zeros and ones, so that our image is more clear, right? So as you can see, the image on our screen is pretty unreadable, but with the help of thresholding, what we can do is that we can thresholding has divided the image into three formats: red, green, and blue. So the parts where the image is dark, it has turned it into blue, and where it is bright, it has turned it into red. A more adaptive sort of thresholding can be done using Gaussian adaptive threshold. It automatically detects where light is low and light is high and distributes the normalization accordingly. Now, moving on to our main topic, that is face detection using Haar cascade. So, Haar features are basically cascade is an algorithm that classifies different sorts of features accordingly and makes decisions on it. You can read more about it on Google Scholar in this paper called Rapid Object Detection Using Boosted Cascade. It's a pretty famous paper. So what we are basically doing is we are using a lot of images and telling our computer that this is the image of a particular thing, and then our computer automatically predicts that particular thing when it comes in front of the camera. So, for example, a dog, we have fed 1,000 images of a dog, and when another dog comes in front of a computer, the webcam of it, the computer can automatically recognize that it's a dog, or a bicycle or a truck, whatever you want it to recognize. Then we have what we have done here is face recognition and eye recognition. So this is me, and I have done face recognition and eye recognition with the help of Har cascade files. So that is that, and this is the code for it. So if you want, I can show you in my Python IDE. So Kinjal is my IDE visible.
Yeah, yeah.
Yeah, so as you can see, I have imported two cascade classifiers from Har cascade files from GitHub, and I'm going to run it. So So as you can see, this is my friend Kenjel who is here in the meeting. So these don't work pretty good for people who wear goggles. So as you can see, this has detected three
Yeah,
eyes.
no, no, the image is not being displayed. Please minimize the PPT.
Minimize the PPT. Okay, wait. Just a sec. Just a sec. Uh, just a second, guys.
Yeah, yeah,
Yeah, is it visible?
yeah. Now it's visible. Can you just show the image to
Yeah.
them?
Yeah, so I have run this code and it has this has been detected. So this is my friend Kinjal, and all of the faces in the photos have been detected, right? And the har cascade file that I have imported from GitHub has not very successfully recognized eyes that have goggles in front of it. So as you can see, this guy has only one eye recognized, and Kinjal has three eyes recognized. So that is that. We can also use sort of webcam face recognition. So live face recognition we can also do. So for that, uh, I have that also. So this is my program. Where we can use webcam to do face detection. So I hope you guys can see me.
Yes, yes.
My hair is pretty messy, but my eyes are recognized and my face is also recognized, as you can see, with the help of my webcam. So that is what I'm trying to convey. So any questions, as
Yeah, for
you
any
guys have?
further, like if you need to recognize your face, like your mouth, your nose, you need to add some additional codings to it, but you can't do it with additional.
You can download a har cascade file from github.com. Okay, I'll show you. Wait. Uh, if you type har cascade GitHub. So, as you can type, here are some har cascade files on GitHub when you visit it. So, there are several har cascade files. There is full body, frontal face, eye tree, profile face, lower body, Russian plate. I don't know what that is. Smile, upper body, the right eye. So, all sorts of har cascade files are there. You can use that, and you can put that in your program and you can run it, and it will automatically detect what is the like if that particular thing is in your photo or your image. So that is that. So any questions or anything?
Devansh, any question regarding this project?
uh, who's the other guy?
Hello,
Krishna
Devansh.
Devan.
Okay, Devansh is not responding. Very good.
Maybe his mic is not working. Anyways, Devansh, thanks a lot for showing interest in our project. We are basically from TEC, you might know that, but and we'll be doing recruitment soon, and we hope that you join our club and show interest in it. So that is that.
Thank you.
Welcome. My project is real-time hand digit recognition. Uh, so my um, my project is real-time hand digit recognition. The basic uh, thing that I want to do, my basic wanting to do in this project was basically to recognize, recognize to recognize is a handwritten digit. The aim is that I'll create a canvas, write a specific number or a group of numbers in it, and the computer or my deep learning code should be able to identify what numbers it is. What I have done is here, I have taken a very basic yet a very powerful data set known as the MNIST data set. In a total, it consists of uh, in a total it consists of 60,000 different it consists of 60,000 different type of handwritten digits. Basically what I've done in this project is create a deep learning model. I've created a convolution of neural networks model. Let's take the number two here. What's happening here is that it takes a specific part of the image and it creates different type of numerical. It creates different type of numerical arrays and matrices so that computer could actually recognize that the number I'm going to input it or the number I'm going to feed it lies between this. So it's trained using the MNIST model. So what it does, it's let's take the number nine here. For the number nine, it converts the features that it should have a loop like this and something like a straight line like this. So the second part basically is the recognition part itself. It's a computer vision part. So computer vision is a very powerful is a very powerful library. So what I do here is it's a very powerful Python image library, so it can do many types of pre-processing in this. So what I do is I write this number for say as I've taken in this example 89 here. I run it through my code. The computer vision part of my code actually recognizes the area where the number is and highlights the important features. Then I put this in again into my model. So that it processes it and then gives me a recognition like this. As you can see here written in blue, 8,98%. So the 98% is basically it's the value that okay, so these are the features of number 8. It's 98% accurate up to that. So this number is 8 up to 98% accurate. Similarly, for 9, this number is 9 up to 67% accuracy. So that's the highest accuracy it's showing. So as per the computer, this is what the number is. So along with the demo here, you can see how the entire thing works. So the entire thing works like this is I write the number like this. It could be done by a stylus, a mouse, or by simply a trackpad input of a laptop. So you can write the number here in the canvas. After that, the on clicking the recognized digit, it will recognize the following. For um, with that, we can just uh, recognize which number it is. It works on a very different and long set. So the main motivation of this project basically is to create an automated system where we can put a camera at somewhere and upon scanning a certain number, it can recognize, okay, these are the numbers that needs to be processed. So this system would be especially efficient in the Indian postal system, where a lot of packages are done. So we write the handwritten address and stuff. So it's very good for automizing that state. So I'll also show you the entire working of the code. So as you can see here, this is the code I have written. So the part before this hashed line basically shows that. This entire thing is the deep learning part, and below that it's the, as you can see, the recognition part. So I'll pull on my canvas here. So as you can see, I've already written the uh, number here. So it's 225. So I'll try with a certain different set of number. Let's say 68. So I can write it 68 and recognize it. So you can see 8 for 99% and 6 also for 99%. So I can say that it's a pretty successful recognition at this point. So another thing that I've done is making this project a little bit more research oriented and stuff. Is I have given a matrix to visualize about how my computer has actually processed the thing. So as you can see, this different type of numbers here. So it might look a bit confusing at first, but it's pretty simple. The first basically shows that uh, what's the probability that the number is zero. So for, as you can see, I have the first number it's recognized as 8. So in this case, so the probability that this number is zero is only 10 to the power minus 10%. Similarly, if you move towards, and for 8, you can see the probability that this number is 8 as per my computer, as per my device, is 99%. Similarly, for the digit 6 or the recognitions I have done ahead is. So that's pretty much it of the project I have made. So a few extensions, if you like to know, is that if you can actually connect a camera, you can click a photo and show whatever you want. Click a photo and upload it to the code, and it will recognize your handwriting as well. So I'll just show you another segment of the code, just to keep things fairly interesting. So one of the most important things that this project requires is the computer vision part. So the deep learning part is a bit complicated. On further knowledge with this, we can move forward and understand. The computer vision part is all this. So from here to here, yeah. So the computer vision part is from this also. In fact, no, yeah. So yeah, this is the entire computer vision part, the blue highlighted area, as you can see. So this basically enables me to find out what are the important regions. If I bring on the image again, yeah. So if I bring on this image again, as you can see, the computer vision part has the job of isolating this entire thing, isolating where the thing is written, making these green boxes, and then feeding this information to the model so that the model can take over and identify and find what's inside it. So if you guys are watching this on YouTube, you should head to our website, and also head to our website. The links are provided there. Like, you can see different type of more projects. If you have any doubts, you can enter the meeting, the Google meeting as we have here. So you can enter this area, enter the meeting, ask us different type of questions regarding this project. My friends and my other teammates have also displayed their projects as well. So if you guys are on YouTube, you should head off to our website. The link would be provided there, and um, look at the different type of projects we have made as a part of this club. So everyone has done something, with be it deep learning, IoT, machine learning, etc. So I'll just play the demo video once again for you to look at, so that you can see that all digits are being recognized accordingly.
Hi, भैया.
Hi, so today our project is bidirectional person counter using IR sensor. Ankita?
Yeah, hi everyone. I'm Ankita and I have with me my friend Shweta, and welcome to Aanvik everyone. So, today we'll talk to you about our project, which is based on an IR sensor. But
Hello?
hello, am I audible?
Yes.
Yeah. So the before we begin with our project, I would like to talk about some applications of IR. So IR vision actually has a lot of several kinds of applications, which include visualizing heat leaks or helping doctors monitor blood flow. Then it can also be used by art historians to see under layers of paint and also make cool night vision cameras. Some other things that you can do is create a very smart thermostat using IR sensors that can perform motion and presence controlled operations to, let's say, save energy. But one application that closely relates to our project would be the use of IR sensors in, let's say, the assembly line of a glass factory, where you can use the sensor to count the number of objects that are being produced or the rate of production. And here also we are doing object detection, the object being us humans. So our uh, objective of the project is to reduce overcrowding in certain theaters or in places of large gathering, in order to not just maintain law and order, but also, as our current situation demands, keep a tab on the number of people gathering together. And it can be used to control the number of people entering a room or exiting as well. So this can be done by counting the number of people traversing in a certain passage or an entrance. It can be used in commercial buildings, say malls or office spaces. And for our project, we send our data to the cloud. So by accessing the data from the cloud, it can be deployed into apps and other applications as well. So the simple outline of a project is all consisting of two IR sensor modules to check the direction of the movement of the person. So as to decide whether the person is entering the room or leaving the room. So what we do is we also use an LED to detect if a person is present in the room. If a person is, then the LED lights up. And if there isn't any person in the room, then it's turned off. So, as we can see through this animation, when the person goes through the first IR sensor and then through the second, the LED lights up. And that signifies that the person has entered the room and the counter has gone to one. So there's one person in the room. Now, let's say the person were to leave the room. Then, if the person was to cross the second IR sensor first and then the first IR sensor, that would signify that the person is leaving, as we can see in the animation over here. And the counter now shows zero. So there's nobody in the room, and the LED has also turned off. So we have used the platform of ThinkSpeak to use it as a cloud service to store our data, the data of how many people are there in the room. And from there, it can be used into other applications as well. So here we have the image of an IR sensor module. It is quite simple in construction. It includes a simple IR emitter and an IR receiver. So the emitter is an LED and the receiver is a photodiode that can detect the light of the same wavelength that is coming. So the emitter emits the IR radiation. If there's an object present, it's reflected from the object and is received by the receiver. And the signal is then processed and sent via the IR sensor. So it consists of 3 pins, the VCC, ground, and the output pin. Next, we would have this diagram explains the same thing, that the transmitter is transmitting the IR radiation and it is reflected from the object surface and is received by the receiver. It can be used to detect the presence of an object. It can also be used to find the distance of an object and for multiple other applications, as I mentioned before as well. Next, we have this is the Node MCU that we have used for our project over here. My French Veta will move on to the demo. We have a demo video, and then she will continue to explain the code as well.
So as you can see in the video, we have made the circuit using two IR sensors as we had explained, an LED to indicate if there's at least one person in the room, and all of this is connected to the ESP8266 Node MCU Wi-Fi module. So now the code for the project has been uploaded, and as you can see currently the number of people inside the room is 0. So now I will be moving my hand to indicate the motion of the person inside the room. So as you can see, the LED is glowing, and on the serial monitor, you can see there is one person in the room. The same value has been uploaded to ThinkSpeak, and as you can see, it is 1. So ThinkSpeak is an online cloud platform where it shows you the live value of the data you are sending, and you can generate a graph of the number of people, and this data is sent to the cloud every 15 seconds. So I will show you how the circuit diagram. So this is the circuit connection. As we had explained, the IR module has a ground, a VCC, and an output pin. The ground is connected to the ground of it's clear over here. So the ground of all, or the both the IR sensors and the LED is connected to the ground of the node MCU. As you can see, the black line. The red line is the power input, the VCC, which is the red line, and the output pins are connected to the node MCU as D6, 7, and 8. So as you 5, 6, and 7. So as you can see, this is the code we have uploaded into the board. So this is where we are importing all the libraries we need for it to run. Here we are assigning the API key and the channel number of the ThinkSpeak ID. Here is the Wi-Fi password and the Wi-Fi name. So in this part of the code, we're setting up the Wi-Fi connection. After this is done, we have set that the output pin mode of the, we have set that the LED IR sensor 1 and 2 are inputs and the LED shows us the output. So the basic code is that it will, okay, so if this is the circuit, it will detect if there is any motion or if there's a person crossing the first IR sensor. If this is detected, then it will check for this, uh, like if there's a person moving across the second IR sensor. And it's the same for the other way around. If a person moves across this IR sensor first, then it detects if the person has also moved across this. So if this is first and then this, then we can say that the person has moved into the room, and the LED glows if there's at least one person, and the counter increases by one. And if he moves out from the opposite direction, then it means he has exited the room. So this is the basic functioning and the circuit diagram and the code of um, the bidirectional counter. So as you can see, this is the output. This is on the serial monitor, and these outputs come on the ThinkSpeak. So as you can see, there are 6 people inside the room. It is shown over here that there are 6 people, and the same is shown in the output. So this is basically our project. Thank you.
Thank you for listening in. If there are a lot of other projects also available, you can visit them all at the Aanvik webpage. The link is available here as well. So thank you for listening in.
करेंगे बट फिर ये लॉकडाउन वगैरह हो गया।
ओह अच्छा, ये सीन
हम्म।
भाई हम लोग
Hello, good evening, everyone. Welcome to Aanvik 4.0. Today, we, the members of TEC, are going to demonstrate our project, which is detection of UID from nanotechnology based RFID tags. So, basically, the main aim of our project was to develop a working prototype to read the UID, which is the unique identification number stored in the RFID tag. Am I audible? Okay. So, the whole project was developed around the Arduino Nano development board. An RFID module was used, and for displaying, we used the OLED screen. We detected the UID, and further, it was displayed on the screen. The developed prototype can be used in various RFID applications like attendance based system, access control, asset tracking, and so on. You can count as well. So, the system architecture flows as we have the microcontroller as the Arduino Nano development board, which is connected to the RFID module, and an OLED display to illustrate the required details that we want to show on the module. Further, the module is connected to the microcontroller, which here we use the Arduino Nano. Simply, we flash the RFID tag on the RFID module, and the details are further displayed on the serial monitor and the OLED display. So the serial monitor, if you've visited Teams 1, 2, 3, or 4, you might have heard about it. Or otherwise, let me tell you, We have Arduino IDE, which is integrated development environment. Basically, we have we display raw data and all of the stuff there. There is This is like pre-inbuilt inside the Arduino IDE, which is functional. So the components of the RFID system are RFID reader, RFID tag, and the application software. Once you flash your RFID tag to the RFID reader, it actually reads the UID number, as I already stated, which is the unique identification number. So that's every time unique. No two simultaneously, like no two RFID tags can have the same number. So that makes the main core of the whole project or the prototype, because every tag has a different UID number, hence can be used in various applications. Further, you can connect the RFID tag to the application software, which can be used for various purposes depending on what application you have to make. So finally, this is how our prototype looks like. We have the OLED display to display the details. This is the Arduino Nano development board. Once we power on it, so it gets switched on. As you can see, the LED glowing here, and then this is further connected to the RFID module. Here we use the RFID RC's 522 module. So the RFID tag is flashed here. It reads the UID number, and then it displays on the serial monitor of the Arduino IDE, or you can read it from the OLED screen. So this is the pictures of prototype of the OLED screen. You have the pre-embedded project info, which is detection of UID from nanotechnology based RFID tag. You have Aanvik 4.0 by TEC. It says to flash your RFID tag, and once you flash, the UID number will get displayed, and this thing can be used wherever you want to. So this is a short clip of the demonstration of how the whole prototype actually works. So I'll play it. This is demonstration video of working prototype of detection of UID of nanotechnology based RFID tag. When we power on the device, product info is displayed on OLED display. Then it asks the user to flash the RFID tag, and then the UID number is detected and displayed on the OLED screen. Thank you. So that's the whole working of the project. So this was developed by TEC and the members of TEC. So you can always join TEC to know more projects like this and invent like them. And in case of any doubts, do ask me out right now. I'll play the video once more in case it was not audible. This is demonstration video of working prototype of detection of UID of nanotechnology based RFID tag. When we power on the device, product info is displayed on OLED display. Then it asks the user to flash the RFID tag, and then the UID number is detected and displayed on the OLED screen. Thank you. So that's how the whole working of the system takes place. For any doubts or queries, do ask them out or listed them out in the chat box. We are always there to clear out all your doubts. Thank you. And do visit other teams as well through the website of Aanvik. And we are live on YouTube. You can always go and watch our live stream right there. Thank you so much.
Hi everyone, welcome to Aanvik 4.0. Today we'll present the bidirectional person counter using IR sensors. And before we do, I would like to tell you about some applications of infrared vision. There exists a lot, many, but I'll just list out a few for you. Uh, First would be that you can visualize heat leaks using IR sensors. Doctors can also use IR sensors to detect and monitor blood flow. It also can be used by art historians to see under layers of paint. It can be used to make very cool night vision cameras and also make a smart thermostat which can perform motion and presence controlled applications to, let's say, save energy as well. But one of the applications that is closely related to the project we're showing here today is something like you can use the IR sensor in the assembly line of, let's say, a glass factory, where you can use it to detect the number of glass bottles being produced and hence monitor the production rate as well. Here, we are not detecting glass bottles, but we are detecting objects such as humans using the IR sensor. Today, I am Ankita and I have my friend here, Shweta. We'll be presenting this project to you. So, talking about the objective of our project, it's based on the idea to reduce overcrowding of places like theaters or large gathering halls. And it is not just to maintain order, but like we know from our current situation, it is also to keep a check on the number of people gathering in a closed area. And it does so by counting the number of people traversing through a certain passage or an entrance, let's say in a commercial building or in malls and office spaces. So you can prevent people from entering a room or allow access if there are few people in that room. And we also, in this project, we send the data back to the cloud. So it can be retrieved, the data of the number of people in the room can be retrieved from the cloud and can be then deployed on mobile applications or websites or for all other purposes. So, coming to the outline of the project, here we use two IR sensor modules to detect the direction of the movement of the person, so as to understand whether the person is entering the room or exiting the room. So, from this, so we can do this by using two IR sensors. And as will be shown by the animation over here as well, this man, while walking from left to right, is first crossing the IR sensor 1 and then the IR sensor 2. That signifies that he's entering the room, and hence the counter on the right has turned from 0 to 1. And the light bulb, LED light bulb that we have, that has also glown. And so that signifies that there's a person in the room. Now, to signify that the person's leaving, what we look at is the fact that he moves first from the IR sensor 2 and then through IR sensor 1. As we can see, the counter has gone from 1 to 0, and also the LED light that was on is now turning off. So we are being able to signify that the person's left the room. And we look into the IR sensor module. It's quite simple in construction. There's an IR emitter and an IR receiver. The emitter is just an LED and the receiver is a photodiode, which is able to detect the radiation of the wavelength that is being emitted by the emitter. And then the IR sensor consists of 3 pins: the VCC, the ground, and the output pin. So in the next, next we'll see that the diagram that signifies if, so the radiation is transmitted by the IR transmitter, right? And the radiation goes and hits the object body. If there is an object present, then it will be reflected back and the receiver will be detecting the radiation again. If there isn't any object, then it wouldn't be reflecting. So if the receiver does receive the radiation that is emitted by the transmitter, that means there's an object present and we can count it as one. It can be used for object detection, the other applications that I mentioned before, as well as to detect the distance of an object. So for this project, we have used a Node MCU, and now my friend Shweta will show you the demo and also explain the project and the code.
Hi guys. So as you can see, this is a circuit connection. We have used two IR sensors, an LED bulb, and all of this is connected to the ESP8266 Wi-Fi module, which is the Node MCU. So the code has been uploaded into the board, and as you can see in the serial monitor, currently there is 0 people inside the room. So the LED is in the off state. Now I'll be moving my hand indicating that there is a person walking into the room. So as you can see, the LED is glowing, and even the number of people inside the room has become 1 in the serial monitor. The same value has been uploaded to the cloud service, that is ThinkSpeak, and as you can see, there is 1 person inside the room. So ThinkSpeak has a property where you can upload values into the cloud every 15 seconds. So if 3 people enter within the 15-second duration, then after 15 seconds, only the last result will be seen. So that value from there can be used to take into an app, or you can send a mail to the person who needs this information. Um, so I'll show you the circuit connection. So here, I'll show you this. Yeah. So here, as we had explained, the IR module has a VCC pin, a ground pin, and an output pin. Now the VCC pin, as you can see, we get the power from the board as the red wire. So all the red wires are connected to the power source. The black connecting wire is connected to the ground, and the output pin is connected to the 5, 6, and 7 pins of the board respectively. So as you can see, this is the code. We have imported these libraries so that the board and the ThinkSpeak, uh, these libraries can actually work in the code. As you can see, 14, it was 13, 14, 12, and 13. So this part of the code is where we are connecting to the internet. So after this code has been after this succeeds, we are declaring that the IR sensor 1 and 2 are the input and the LED is the output. So the basic functioning of the code is that we are setting up a variable. So now a person if this IR sensor 1 detects a person moving across it, it will initialize a variable to check if the same person is crossing this room. So if that variable is true, then we can say that the person has crossed the room and the counter increases by 1. Similarly, if the person first crosses this IR sensor, then another variable is set up to check if he crosses this sensor. So the number of the counter value decreases. So, and this LED as shown is connected, and this will glow only if the number is greater than 0. So this is basically the code and the circuit diagram. So this is the output on the serial monitor of the Arduino IDE, and this is the output on the ThinkSpeak. So as you can see currently now, there were 6 people in the room, and as you can see the last value over here is 6, and this value, the counter, is 6. So this is basically the output we receive on ThinkSpeak. So do you have any doubts? Do you have any doubts about how the IR sensor actually detects the value or anything? If you have any doubts, let us know in the chat box or you can speak up.
In case you do not have any doubts, there are a lot more very interesting projects present for Aanvik. Feel free to check out our website and go on to the other meets that are there for the other projects. We are also having our YouTube live on right now, so you can keep an eye out on that, and we're presenting over there as well. If anyone has any doubts, we are here. Feel free to leave a message, or you can turn on your mic.
Guys, Surya. Hello.
Yeah. Hi guys. Hope you're doing good. Myself Yash Surya, along with my friend Yash Rajgure.
Hey guys.
Yeah, I'm audible.
Yeah, you're audible. Go on.
And our project is temperature and humidity measurement using DHT11 sensor. So before starting, I'll give you a quick overview what all we'll be explaining. First of all, I'll tell you about the components required to build this project. Then the connection, the explanation, and the working. And in the end, we'll show you a working prototype video for the same. So let's get started. The components required are node MCU, female to female jumper wire, a DHT sensor. So a node MCU is a microcontroller just like Arduino, but it comes with an inbuilt Wi-Fi module, which is a very inexpensive system on a chip SoC called ESP8266. And you program this chip using low-level machine learning instruction, which can be interpreted by the chip hardware. And the next thing is our main sensor, which is DHT11, which is used to measure the changes in humidity and temperature. Next slide. So this is our basic connection. The DHT sensor consists of three pins: VCC, out, and ground pin. So the VCC is connected to the VN pin of node MCU. The ground is connected to ground of node MCU, and the out pin is connected to a digital pin of node MCU. So there are multiple digital pins: D0, D1, D3, D4, D5. So we have connected it to D4. Next slide. Now Rajguru will explain the same.
Hey guys, so let's look at how the main things which we are using, the DHT11 works. So the DHT11 sensor basically has a capacitive humidity sensing element. So basically everyone knows what a capacitor is, right? So between the capacitor, it has a dielectric such that has the ability to hold moisture. So depending on the surrounding humidity level, it absorbs and lets go of moisture, and hence it changes its dielectric constant. The change in dielectric constant changes the capacitance, which can be easily calculated, and hence we can get to know what the actual humidity of the surrounding is based on a sort of a reference. The temperature, on the other hand, is calculated using a thermistor. A thermistor is basically a sensor which changes its resistance based on the temperature which it is kept in. So, what we have in the DHT11 is a negative temperature coefficient sensor. What it means is it basically it decreases in its resistance value. There is a decrease in its resistance value whenever the temperature of the surrounding increases. So over here, similarly, based on a reference, we can calculate how much change there is in the temperature and how much change there is in the resistance, and based upon that we can interpret how much change there is in the temperature of the surrounding. We are doing all of this, and the data is passed to the node MCU. A node MCU is basically a microcontroller such as an Arduino Uno, if any of you guys have used it or heard of it before. So it has an embedded Wi-Fi module. An embedded Wi-Fi module is so that you don't have to go out and buy a separate module as you have to do for Arduino Uno. So Node MCU can directly do it on the with just the board. You don't need to buy any extra component. So next we'll look at a small working video which we have over here. Okay, let me just play it. So, okay, the first thing out right across the bat we have over here is the Node MCU. The Node MCU, as you can see, is in my hand, and it's connected to the laptop using a micro USB. And as you'll see, the Node MCU is connected with the female to female jumper wires, and it is connected to the DHT11 sensor, which is responsible for all of our measurements and sensing of the temperature and humidity. So as you can see, this is connected to the laptop. And what we have over here is the Arduino IDE. Arduino IDE is basically the IDE, the software which is used for programming boards such as Arduino boards mainly. And it can also be used to program Node MCU. So it's pretty useful, and yeah, the programming language is similar to C or C++, you can say. So as you can see over here, it says done uploading. So I've connected my Node MCU to the laptop. With the help of the Arduino IDE, I've uploaded the entire code which I've written to the Node MCU. And now you'll see over here, it is the serial monitor. A serial monitor is basically where you show whatever data you want to show to the whatever data you want to print. So over here it says Wi-Fi connected. In the code given, I have already specified the name of the Wi-Fi which I wanted to connect, and also the uh, password of it. So with that, it can easily connect to that Wi-Fi, and it tells us over here that the Wi-Fi is connected. Then it gives us, and as soon as the Wi-Fi is connected, it immediately starts sensing and printing the temperature and humidity values. Over here, as you can see, it says temperature is 28.8 degrees Celsius and humidity is 48%. After it's detected this, the next thing it says is sending to ThinkSpeak. So if you guys have been to other project, especially Team 3 project, there they also use the ThinkSpeak platform. If you haven't, I'll just tell you what it is. Okay, sorry. Started over. My bad. Yeah. So what ThinkSpeak is basically it's a IoT cloud platform which allows you to back up things which you sense using IoT devices, and so this is basically the ThinkSpeak. So it allows you to store the values, and it also has an inbuilt plotter which is very useful. It's linked with MATLAB, if you guys have heard about it, most probably in your first semester or something like that. You've come across MATLAB in your calculus class. So this it uses MATLAB to plot the values which you are providing it. As you can see, there are two graphs over here. One is the temperature versus time, and the other is humidity versus time. So I've recorded a few values earlier before this value you saw. So the value which we saw is it was 28.8, remember? So over here, as you can see, it's plotted 28.8, and over here it's plotted 48%, I think it was. Yeah, so it's plotted those values over here, and then so you'll see now it we'll see one more value being plotted in just about a sec. The thing with ThinkSpeak is that it requires a minimum of 15 seconds between two of its consecutive outputs, and it's not very fast. So that's why, even though the DHT11 sensor can sense two distinct values in between just a second, ThingSpeak platform requires 15 seconds. That's why it takes a lot of. That's why it takes some time to upload the values and for it to reflect over here. So that's why we are sensing using the DHT11 after about 15 seconds, give or take. So that's what we are doing. This is a project. This is a very simple prototype, and the actual purpose of temperature and humidity measurement is in industrial level, where you need to know what your surrounding temperature and humidity is in order for your products or whatever you have, or your steel or whatever it is, to be safe and not to react, or like for it to stay longer. So you need to maintain some proper temperature and humidity, and these sensing elements are very important. This is just a prototype. It is not an industrial level application, and although the application is there, but this prototype can't be used for industrial level. So that's basically our project over here. And if you guys have any doubts, please do ask them, and we'll hopefully try to answer all of it. And if you guys don't have any doubts, you can head on to the Aanvik site, and you can go to other projects. You can go to many different projects. We have quite a lot of going on over here. And if not, you can go directly to the YouTube link, which we'll get in the chat box. Can someone please get the YouTube link in the chat box? So you can directly go to the YouTube link. The site link is already in the chat box. Go over there, head on, watch the other projects. They're pretty good. And if you guys have any doubts, please tell me. Please tell us. We'll solve them for you. Anything you'd like to add, Surya?
Yeah,
थोड़ी आता है VIT में.
I think uh, I think someone has joined.
Yeah. So okay.
Hello,
Yeah, you should.
free, a free. Uh, hello,
Soumitra, can you
uh,
just share the screen?
share my screen.
Yeah, yeah, yeah.
Share. Is it visible? Hello.
Yeah, it's visible. It's visible. Yes. Okay.
Okay. Hello. My name is Soumitra Singh, and our project is object detection using OpenCV. And my partner is Kinjal, who will explain you about the project.
Yeah, so basically, detection using OpenCV, basically, it includes computer vision. Now, what do we know about computer vision? So, basically, computer vision task includes methods for acquiring, processing, analyzing, and understanding digital images and extraction of high dimensional data from real world in order to produce numerical or symbolical information, like for example in the form of decisions. So in understanding in this context means the transformation of visual images into description of the world that makes sense to thought processes and can be used in appropriate actions also. And this image
That
understanding can be seen as well as of symbolical information from image data using models constructed with the aid of geometry, physics, statistics, and learning theory also. Moving on, Soumitra will explain you the how to apply the code in the specific CV model. Soumitra.
yeah, yeah. So yeah, yeah, yeah. So okay. So the Computer vision for from amateur to a mediocre level, the main library that is used for computer vision is OpenCV, which is available on Python, Java, C++, and OpenCV has more than 2,500 optimized algorithms for your day-to-day needs. It has uh, yeah, you can basically do a lot of stuff with OpenCV. Some of them are on the screen on the right. Some companies that use OpenCV for their go-to operations are Honda, IBM, Google, Toyota, Yahoo, many other MNCs. Intel is actually the company that has made OpenCV. So some of the very basics operation of OpenCV is like drawing text and shapes on images. So as you can see, I've drawn certain kinds of shapes and written some text on the image of a watch, right? You can do that easily with OpenCV. So this is the code for that. Another thing is thresholding. So thresholding is basically partitioning an image into foreground and background. So basically, uh, in simple language, what is happening is every image is made up of pixels, and these pixels are nothing but basically arrays. And in these arrays, there are numbers, and when these numbers are altered, right, the image changes, right? The so sort of when you like edit your image. What basically on the backend what is actually happening is these arrays, the number that are presented on these arrays are changing, right? So in thresholding what we do is that we change these to a certain extent. We change according to our thresholding values, we change these values in the forms of zeros and ones. So there are certain level of thresholding like multi-level thresholding, set level thresholding, etc. So one of the operations that we did was so this is an image as you can see, and it is barely readable. And once you perform the thresholding operation on this image, yeah, wait, yeah, so it has converted it into 2 or 3 colors, and now it is more readable, right? So it has basically segmented the images into two three actually 3 colors: red, green, and blue. So the place where light is more it is more red, and the place where light is red it is more blue. So that is that. And another kind of threshold is adaptive threshold. So here the algorithm already detects where the light is more and where light is less, and it normalizes the entire thing. So as you can see, it is much more better than the previous one. It is actually yeah. Moving on to our main project is face detection using Haar cascade. So, in simple language, what we are basically doing is that we are showing a lot of images to our computer, and we are telling it that the object present in this image is a particular thing, right? And then we're doing that at high scale. For example, we're showing 1,000, 2,000 images to a computer, and then our computer is recognizing the fact that this particular object is this. So, for example, I'm saying that this is an image of a cat, right? And then I'm showing like 2,000, 3,000 images of a cat. The computer slowly starts learning the fact that this is a cat, right? So the next time, the 3001th time you will show the computer the image of a cat, there's a high chance that it will recognize this. This is known as Viola Jones algorithm, right? And so for example, you show we feed it you can feed it the images of dog, bicycle, truck, etc. So yeah. And then so this is our project. I did face recognition in face recognition and eye recognition. As you can see, my face has been recognized and my eye has also been recognized, and the code for that is this. So for doing that, you have to make your own Haar cascade file, right? And to make your own Haar cascade file, what you have to do is you can basically you will have to do the same process that I told you before, or you can download it from GitHub. So if you can just go to github.com, and there are many Haar cascade of several objects already available there. right? So now if you want, I will show you how this works. So this is uh, here what I'm trying to do is I'm trying to feed in an image, and then doing the face and eye detection procedure on it. So yeah. So as you can see, four faces have been detected, and the thing is that the eye detection doesn't work quite well for the people who have wore a glass. So as you can see, this guy in green kurta has three eyes detected, so it might be the reason because he's wearing glasses. So for that there are other you have to feed in some images of people wearing glasses also, and then tell your computer that yes, this thing is also an eye, right? So for this guy who hasn't wore a glasses, both eyes have been detected and the face have also been detected. So that is that. So yeah, wait. Okay, I think some problem is there. Yeah. Anyways, any questions? Yeah, I have restarted my kernel. So yeah, that is pretty much our project. Any questions? I think there are no questions. So great.
Guys, any doubts? You have any doubts regarding?
No, okay. So, anyways, we are from a club called TEC, and our recruitments will be beginning after after this semester. So, we hope to see you in the recruitments, and like it is a pretty cool club. Kinjal will explain you more about it.
Yeah, thank you for joining today. You can follow our Instagram page, tc.vit. We will post the updates regarding recruitments in the Instagram handle itself. So, yeah, you could join us when our recruitments will start. And thank you for joining today. Thank you very much, guys.
Yeah, also, you can also use your own webcam to detect your eye and your face. So, just a second. Yeah, so I restarted my kernel, and now, yeah, so you can use your webcam.
Soumitra, is it responding? Like,
Yeah, it's working, but pretty slowly.
oh, yeah.
Yeah, as you can see, my face and my eye have been detected with the help of uh, my webcam. So that is that. So that is also possible. So it's a pretty simple project. Everyone can do it. Depends on you. Also, you can check out our other projects on the in the option where we are showing it. So there's one project about handwritten digit recognition. You can check that out. We have also a project about uh, person counter using bidirectional IR sensor, which is pretty cool. So you can check that out. And any questions, if you want to ask, it is entertaining. So it go.
That they don't even need a battery to store information and exchange data with readers. This makes it cheap and easy to apply tags to all kinds of things that people would like to identify or track. So the RFID tag is flashed on the RFID reader, which is connected to any application software depending on what application you want to make out of the RFID system. This is the picture of a prototype that we developed in TEC. This is the OLED display on which we have copied the screens of what was displayed in stage 1, 2, 3, and 4. We have the Arduino Nano development board as the microcontroller for this project, and we have the RFID module. In this case, we use the RC522 series. You flash your RFID tag here on the RFID module, which reads the UID number, which is the unique identification number, and this further gets displayed on the screen. So in stage 1, we have the name of the project, which is detection of UID of nanotechnology based RFID tags. We have Aanvik 4.0 by TEC. Once it tells you to flash the RFID tag, the user flashes the RFID tag, and finally the number is displayed. So hence it can have various applications. Now let's finally move on to the most interesting part, which is the working or the demo video of the project. So let me play.
This is a demonstration video of working prototype of detection of UID of nanotechnology based RFID tag. When we power on the device, product info is displayed on OLED display. Then it asks the user to flash the RFID tag, and then the UID number is detected and displayed on the OLED screen. Thank you.
So that's how the whole project works. So that was all about this project. If you have any doubts, feel free to ask them right now, or do type out in the chat section. And you can always visit TEC's Instagram handle or any social media handle to contact us for all kinds of queries. And do try to visit other platform. Do try to visit the other projects that are at hand on the TEC's website, which is anvik.tecvit.in. We have various projects to display to you, and you can always come to us for all details. Do ask your doubts in case you have anything. Thank you.
Mm. Uh, okay, so guys, welcome. This is real-time handwritten digit recognition. So this project I have made with the basic motivation of detecting a handwritten number. So about regarding that is that I have made a code such that it has a canvas. I write a specific digit on the canvas. Let's say here I've written the digit of 89. After that, this will show processing this processing this written digit through my code. It should show that which digits have been written. So as you can see here in this blue writing, 8 at 98% and 6 at 9 at 67%. So for the basic training of for the training of this purpose, that I have used the MNIST dataset. So this is a full snippet that I have taken from my project. So this data set is actually quite a huge data set. It has 60,000 different it has 60,000 different types of these images that will help us to create a deep learning model. So the deep learning model, basically, I have used is known as the convolution of neural networks model. So it's a very highly used deep learning model nowadays when it comes to images. So what it does is it takes a particular segment of an image. Say for this, it takes this segment of two. So it creates number of features. Features are nothing but mathematical arrays. Um, to show all this. So these are nothing but mathematical arrays that the computer will use to find out what number this written or this scribbled thing is closest to. So this is one of the this is a quite simple notation of how a neural networks looks like. So all these in between is basically hidden layers. This is the input layer and these are the output layers. So, moving forward, I'll basically show you just a demo on how the entire project works. So, as you can see, if I click on this recognize digit button, it will recognize the digit I have. It will show it will show a zero for when it's moving on with one, and it shows specifically. So rather than boring you with this video, I'll actually show you about the real project, the real deal. So, so this is the code that I have written. As you can see here, I've directly taken this photo that I used in the presentation. So the code I have written, the things above this hash line is basically my deep learning model. I've used the MNIST library, as you can see the one I've highlighted here. So moving forward, the below this hashed line is basically my this is the recognition part, the entire recognition part. So this entire part where this def widget activate events are all part of the canvas. And finally, from here, it does the model.predict, it recognizes what number I've written. So showing you a live demo. So this is clearly a number that I'd written earlier. So I'll show you a number this time. So with this, let's say, okay, it's written it too big. So let's say I've written a number 26 here, something of that sort. 26. Um, let's take 268 for the example. So 2, 6, and 8. We recognize the digit. So it first recognizes 8 here, then we move forward, it recognizes 6 and 2 here. So I'll also tell you one of the most interesting aspects of my project. I'll also tell you one of the most interesting aspects of my project. That is, it's a research based aspect. It actually shows you how the computer thinks. So as you can see, it's recognized 8 here. If I bring this on image once again, for 8, this probability that the scribble is a 0, it shows at 0.15%, versus if we look at uh, it shows at 1.71 into 10 to the power minus 8%. Whereas if we look at 8, you can see it's 99% probability that the number is 8. So this is kind of a research prospect that actually shows how my computer model is thinking and it's working. So if you guys have any doubt, you can ask me, put it in the chat box. I'll be happy to answer any one of your doubts. Before, I would also like you to say that my friends and my teammates have made excellent projects. You should go and visit them here on our website, Aanvik, tecvit.in. Um, if you guys have any doubts, anything you want to clarify, I'll be happy to answer your doubts in the chat box. So keep in coming. Um, Thank you guys for joining. So if you have any doubts, anything, you guys can go ahead and uh, have a look at the website. You can thank you so much for taking your time and joining us. Do follow our social media pages on Facebook, LinkedIn, and Instagram. You'll get more regular updates of the projects we make or the different type of events that we do. So see you around. Thank you.